So let's continue. Armed with the theory of quadratic functions that we looked at in the previous video, let's go ahead and do some graphing. Remember, you've got that awesome calculator available to you to help you as you go through these. So we first want to graph y equal negative 2x squared. So let's just practice determining some information about this quadratic. The first thing is, how does this guy open? When you look at a quadratic, you need to know what direction that parabola opens. And remember, it's based on that leading coefficient, in this case, negative 2. So since it's negative, it's going to open down. And when a quadratic opens down, I know that the vertex is a what? Maximum or minimum? The vertex is a maximum. So I know that about it. So I know it's opening down. Let's just go to our calculator and see what the graph of that looks like. So I've already got a couple of these in my calculator. So let me turn that one off. Let me turn that one off, and let's graph negative 2x squared. So yes, it's a parabola. It's opening down, and the vertex is a maximum right here. What I want you to do when you're graphing these is go to the table and let's get some ordered pairs. Clearly we can see the vertex is at 0, 0, but let's get a couple of other ordered pairs for it. So I've got 0, 0, and I've got the point 1, negative 2, and I've got the point negative 1, negative 2. Those are enough values that's going to enable me to graph this parabola. So vertex is at 0, 0. 1 went down to negative 2. Negative 1 went down to negative 2. So notice how I'm wanting some specifics here. And let's just draw that parabola opening down. 1, negative 2. Negative 1, negative 2. And there we have 0, 0. So there is our vertex. That 0, 0 not only is the vertex, but it is also the x-intercept, and it is also the y-intercept. Imagine that. So there we go. We've graphed our first quadratic. We've got the x-intercept, the y-intercept, the vertex, and a couple of extra points. So definitely going to utilize the calculator. So let's look at the next one. Okay. First thing I want you to tell me is, how does this guy open? Up or down? Well, it's based off of that leading coefficient, and since that guy is negative, I know it's going to open down, and I know the vertex is a maximum. Okay, let's work on finding another important piece of information from this equation. Let's actually find the vertex. Remember, the vertex is an ordered pair. We called it h comma k, and the h came from inside the parentheses, the inside number, and the k came from the outside number. So there is my h, there is my k, so my vertex is at 3, 8. Now you might think I made a mistake because I wrote that as a positive 3. But when you're getting the vertex from your equation, you have to think about what we did earlier in chapter 2, our shifts. Remember, the number on the outside tells you where to go according to the sign. So it goes up 8. It's a plus 8. But the number that came inside, we had to do the opposite direction. So remember, the number inside told us to go left or right, and since it's a minus 3, we would actually go to the right 3. So when you're getting that vertex, keep this in mind. For the h, we do the opposite sign, and for the k, we do the same sign. So let's just kind of put that over here and see what we've got so far. So I've got a vertex at 1, 2, 3, over 3, and up 8, 5, 6, 7, okay. Over 3, up 8, there is my vertex. I'll label it with a V. And we know that it's opening in what direction? It's opening down. Okay, so with it opening down, I can clearly see there's going to be a y-intercept where it crosses the y-axis. There's going to be some x-intercepts where it crosses the x-axis. So I need to find those values. So let's go with the y-intercept first. For the y-intercept, remember we let x be equal to 0. So I'll have a negative 2 times 0 minus 3 squared plus 8, which will be negative 2 times 9 plus 8, which is negative 18 plus 8, which is negative 10. So my y-intercept is at 0, negative 10. You need to be able to do this algebraically like I just did in this example. So my y-intercept is 0, negative 10. There's my y-intercept. So if I drew my parabola, I can see that it's crossing the x-axis in 2 spots. So I need to find my x-intercepts. And if we look back at our theory, we find the x-intercepts by letting f of x equal 0. So I'm going to take that function, negative 2, x minus 3 squared plus 8, and set it equal to 0, and let's solve it. So to solve this quadratic, we're going to need to use the square root method. So if you worked on that quadratic equation review, then hopefully you'll remember how to use the square root method. First thing I would need to do would be to subtract the 8. Then I would need to divide by this negative 2. And then to get rid of the square, I would need to square root both sides. And when I square root both sides, I got to remember to put in the plus or minus. Okay, so the square and the square root cancel. I have x minus 3 equal positive and negative. Square root of 4 is just 2. So that means I've got x equal to 3. Bringing the 3 over, it's subtraction, so I add 3. 3 plus or minus 2. Finishing this off, I get 2 answers, a 3 plus a 2 and a 3 minus a 2. This answer is 5. This answer is 1. So we were finding x-intercepts, and for an x-intercept, the y value is 0. So this would be 5, 0 and 1, 0. Let's see if those make sense. Here is 5, 0, and here is 1, 0. There's an x-intercept there and an x-intercept here. Everything lines up. We can now graph our parabola, connecting the dots, showing that it's opening down and it's going through those y and x intercepts. And there we are. Let's show, or let's prove that or check our work on the calculator. So let me turn actually that guy off. Let me turn this guy on and let's graph him. So we can compare. See, the vertex would be there. Looks like that's at 1. Looks like that's at 5. And I guess maybe if I traced along, here's a really cool thing. When you graph a function, immediately after graphing it, if you press the trace button, it will always automatically go to your y-intercept. And so notice my y-intercept was at negative 10. So I see that matching up. Then if you wanted to trace along, just kind of tracing along your graph, you can see those ordered pairs there at the bottom. Now, unfortunately, it's not going to show you exactly what they are, but you can see it was at 3, whoops, this was at 3, 8, and looks like that's right around 3, 8. Let me show you how you could find it exactly on your calculator. Let's recall this feature, second calc. Oh, maybe I didn't talk about this one. Maybe I did. Now I don't remember. But anyway, since that vertex is a max, let's choose the max feature. And when you choose either the max or the min, it's going to ask you to put your cursor on the left side of that max or min and press enter. Then move your cursor, pass it up and move your cursor to the right side and press enter. And when it says guess, press enter again. And 2.9999996 is the same thing as 3. The y value is 8, so checks out. If I wanted to look at my x and y, my x-intercepts, then I can go to second calc and choose this 0 feature. Or, hey, how about we go to the table? Let's look at the table. Looking at the table, I notice that, I have an x-intercept right here at 1, 0. There he is. And if I scroll down, I've got another x-intercept at 5, 0. There he is. So let your calculator help you as you work through these graphs. All right, let's look at this next one. So let's start off. How does this guy open? I'll kind of go back to the blue. So let's pick up some blue. All right, so how does this guy open? Remember, it's based on the coefficient in front. And since it's basically an understood positive 1, it's going to open up, which indicates that my vertex is a minimum. Okay, the way we find the vertex is we use the h, k notation. So the vertex is -3, 1. Remember, we do the opposite sign of the number in the parentheses, same sign for the number outside the parentheses. So let's just kind of see what's happening with this. So let's go with pink. So vertex is at -3, 1, right there. And it's going to open up. Just quickly drawing that in. That's not accurate. But this is what I want you to realize. The vertex is here. It's opening up. Will I ever have x-intercepts for this particular quadratic function? And I won't, because it won't be crossing the x-axis. So what's nice is there aren't any. So I don't want to try and find something that doesn't exist. So the x-intercepts don't exist. But because it's opening upward, I see it's going to cross the y-axis somewhere. So let's find the y-intercept. And remember, we find that by letting x be equal to 0. So I have 0 plus 3 squared plus 1. 9 plus 1, which is 10. So the y-intercept is at 0, 10. Connecting the dots, forming a parabola. There is the shape of the graph of this function. And let's check it out on our calculator. So go to y equals. go ahead and type that one in. I already have mine typed in, and let me turn it on. Okay, so I see similar shapes. If I hit the trace button, it automatically goes to the Y-intercept, which is what I found earlier. And let's go to the table to get a couple of points. So what about, let me go up a little bit. Let's see, -1 right here goes up to 5. All right, got that point. And then let me back up a little bit more. And what about -5? He goes up to 5. So those are 2 points on my parabola that describe the width and give me some definition. I will stop this video right here, but as you're working through the homework or as you're watching the videos and you have questions, please let me know.